Thank you everyone for coming. This is actually a very special occasion for us. This is the first time we will be presenting the OWASP Coraza project. Although the project has been there for more than 3 years, we are finally releasing really stable versions of the project with great users and companies making good use of it. So we're going to take you in a journey through the story of web application firewalls and how we came to the new generation of web application firewalls that are required by the current market. So my name is Juan Pablo Tosso. I'm from Chile. I am the author and co-leader of Coraza. I will work in cybersecurity I have been working on it for 10 years. Right now I work at Traceable, and I dedicate my career to API security.
And I'm this guy, Felipe Zipitria. I'm the CRS core rule set co-leader. Coraza co-leader also, which is a good synergy for us. And long-time supporter of many OWASP projects and chapter leader back in my home country in Uruguay.
So maybe most of us remember the 90s World Wide Web. We have fancy cursors with background music, marquees everywhere, and well, not even servers are rendering, like static HTML with some CGIs receiving forms. So when the internet was dissolved, we were looking for vulnerabilities that will actually really affect users and companies, like cross-scripting, SQL injection, and many vulnerabilities that have changed or mutated in time in terms of risk and what can happen to you as a victim of the attack. Also, well, we had HTTP 0.9, which only supported the GET method and wasn't fun enough to do complex attacks like today. About the first WAF. The first WAF attempt was a company called App Shield in 1999. They tried to create the first web application firewall that will actually read the HTML and the HTTP request and response. The concept is very similar to what we see today. Basically, they will have sets of rules that applies policies to the content that is received by the server and sent by the server. And in 2002, we have the first version of mod security. I guess most of us know mod security. It's like the world's most renowned web application firewall that works as a web server, web application firewall, and right now as a library. Then it's super important that we have a great game changer that was the OWASP Top 10 that generated the standard of what will have to be protected by the WAF, because it created the first concern of what should be protected by what are the vulnerabilities that we should be taking care of in the WAF.
So in 2005, we get the WAF, which is the Web Application Firewall Evaluation Criteria, which was a document created, co-joined by OWASP and the Web Application Security Consortium, the WASC. And it's a standard to define what a WAF should do, how do we evaluate WAFs, what are the concerns that we need to have on them, and how they are supposed to do the things. That's a version 1.0 of the document. There is a version 2 on the making, but it's been since some time, I think, without leader or without too much engagement on the. But I think that we are going to expose some of the things that we were talking on the new and the evolution of the WAFs that might be affecting by the WAF. And in 2013. We have the version of the public core rule set, which is my other project, and it was released in GitHub for public consumption. The idea was it comes out from it used to be a commercial rule set, but then it was free at some point. we know that it was around in the public SVN, but it was lost in translation somehow, and there is no older version that we can find out. So 2013 is the day that we are looking at for the public CRS availability. Mole security. So as we said, mole security was the first open source WAF. We are talking loosely about the term WAF here. It was basically a module, an Apache module. That's why the mod _ security. This version rely heavily on Apache for working. So it was basically dependent on the life cycle of hooks in Apache. Basically, that was the main capability. We defined in Apache like 5 different phases, which are the phases that really we are using up to now for blocking. So we rely on the phase 1 for headers, phase 2 for body, 3 and 4 for the response. And it was clearly the place where the hook was made in Apache for being called as a module. So that was basically setting the standard at the moment. And we are still using that thing. The other thing that arises with the module was a way of configuring it. So we have basically configuration of directives for the engine itself. So we are telling mole security behave like this, do this, use these limits for things, files are this big or not. And then there is a rule engine for actually writing rules for blocking or allowing traffic, right? And this was very dependent on the Apache language itself. And that's why the seclang or something known the seclang was born at the date, right? The thing that we have with mole security right now is that is actually reaching end of life in 2024. So for us that we use open source software since a long time, this is a critical moment that we are reaching.
So implementation techniques in the early 2000 years were basically in line or out of band, where we will have a reverse proxy, a transparent proxy. We will embed the web application firewall as part of the web server, or we had the alternative that was the most common at the time, that was traffic mirroring.
Well, as I said, the core rule set. Well, with the creation of the engine, the idea is like basically you have the way to express your security policies in a way that will affect the traffic that is getting into your applications. So with the idea that we can execute these rules, there was an idea can we do a common rule set that we can use to protect any application in a way? So the Coraza was born initially inside, we said Trustweb, but it was Spider Labs, the first, basically the core rule set. And at some point, it was wisely handed to the community for its maintenance. So the company moved basically the core rule set to OWASP at the point.
Well, now we'll go through what will be the beginning of the Web 2.0. So it all starts with rich content application. Although in the early 2000s, we still had rich content application and chat applications and other kind of rich context. For the case of applications in general, something changed. New frameworks, for example, ASP.NET will provide you with the XML X ActiveX. You will install it and you will get hacked, but still. Then we came with JSON or RPC or JSON RPC, other standards that will enrich the application with what will eventually become the API calls. This created a huge change that hasn't been properly addressed until now by the existing web application firewalls. The APIs and JavaScript frameworks has changed how we interact with web application. Instead of server-side rendering, our JavaScript code is calling the data directly from the server. We have multiple data structures that we can consume, like GraphQL, or we can use RESTful APIs and JSON or XML. And some of the logic, business logic, has been transferred to the client, which isn't okay. I mean, maybe there should be two copies, the server and client, but it created a new gap in cybersecurity where companies or developers will think that by protecting their data in the client side, it's also protected on the backend. Now we're going to go through the ways of integrating a web application firewall in the Web 2.0, which is actually where we are right now.
So eBPF, it's a new framework that basically it's arise. There are many security tools that arise with the upcoming of the eBPF. It's basically something that you can execute at the kernel in Linux, and it can be used by so many things. It's being used by, I don't know, in many Kubernetes tools and many observability tooling, tracing, others. So basically what we think is that it can be used by reading HTTP and even Open SSL or SSL in the end. So basically we can read encrypted traffic at the host that is being executing the eBPF. So it's a new way of getting up to speed with new techniques for doing basically reading of the web transactions. So the only problem we have is that at this moment we cannot terminate a session in the eBPF. So basically we can read at really high speed, but there is no way of, if we see an attack right now, to just block the attack or terminate the connection. So this is an interesting challenge that we have, but this is a good thing that is happening now, and I'm glad we are at this moment and talking about
it. Tracing is a recent technology that's being used to transform metrics and data into a data structure that can be handled by some collector that will do some post-processing over it to generate statistics or anything that's your requirement. So today we have seen that companies are also making use of traces to generate WAF results, actually. So a trace with all of the data of a web request can be enriched with web application firewall rules. And it also doesn't support blocking. We are talking about an asynchronous mechanisms. Actually, this is super interesting because most modern web servers are providing tracing capabilities. So basically, if you have a tracing server that a tracing collector that has a processor that performs some WAF operations, you will be able to automatically connect your WAF asynchronously to your web applications. We also have gRPC. So gRPC is a binary implementation that allows you to transmit protobuf files or binaries. So it is really interesting, and we have seen it a lot in a lot of use cases that companies are using sending their data from their applications or from their web servers directly to a web application firewall gRPC server, and they can even take disruptive decisions. This is really interesting because it can be used to approaches like RASP or WAF, and it can be easily integrated into applications. I mean, if you have a single WAF and you want to connect it to Node.js, Python, PHP, and all kinds of languages, you can use the same proto interface to connect your web application firewall. SPOA, it's a fun one because in Coraza we released an SPOA connector for HA proxy, but it was just an experiment. But somehow so many people started using it, and it's not stable, and It's really cool how it works. So SPOA provides a protocol of communication between your server, your HA proxy, and some application. So from the HA proxy side, you will send some data like the request body, URL, headers, or whatever you want to share to the web application firewall. And SPOA can return a list, a map of objects that you can later use to consume, to take decisions. For example, you can create an if in HA proxy that says if the WAF disruptive action was denied, let's deny the connection. This can be used for termination or many things that you would like to use as features. And finally, WebAssembly. This is the most interesting experiment we have been running in the last year. So WebAssembly is a standard that allows you to compile a binary into something that can be consumed by the same virtual machine or the same processor, independent of the language. There is a standard called proxy WASM. So if you create a binary using the proxy WASM standard, and then you compile it on Golang or on any language that has a WebAssembly compiler, you will be able to run it everywhere where it is supported. So this is super interesting because we think this is the future of plugins for proxies. Right now, Envoy is using it. It is super important for Envoy, but we really expect for the following years to become the standard of plugins for Nginx, Apache, and all web servers. So you should be tuned to it. It's really interesting how it works, and we will see an example at the end. About the challenge we're having right now.
Yeah, so we are having some challenges that because the web has evolved, right? We are using new techniques to send and receive data, and we are consuming different interfaces that we were not using years ago. So some time ago, we created WebSockets, which is a way of sending both audio and video. It's very used for normally audio, video, but any stream that you can do because it's a bidirectional string between the server and the client. So it's normally being used for audio and video, but it's being used also for sending any information that you can stream. What we observe is like the basic information that we are sending is like 80% or more even JSON streaming. So basically we are consuming APIs, so consuming data, and we are sending JSON along the way. And even if the data is not standard HTTP, we can read that stream if it's JSON. So it's challenging if we are talking about binary protocols and we are sending video encapsulated or audio encapsulated. But if we are just sending data that we can read, then why not protect it? Can we protect that data if it's a JSON that it's just being streamed from client to server? So that's an interesting challenge that it's happening now, and we don't want to look the other way.
So other interesting point about WebSockets is that there is a question that should WebSockets be protected by the web application firewalls? That's actually something we're not even sure, but there's a problem there. So we have reviewed all of the proxy APIs, Apache, Nginx, Kali server, Traffic, everything, and there's no way to hook ourselves to the WebSockets. So should it be another layer of security? What should be the approach? Should the web servers themselves add APIs to take control of WebSockets? This is a huge question that we're constantly discussing. And GraphQL. So right now, many APIs have migrated to GraphQL. What's interesting about GraphQL is that it returns what you want, and you can perform queries, and you can perform mutations on the API. So the problem is that it is basically a JSON, but it contains a query and data in a format that is not JSON. So we enter a problem. How do we read that data, and how do we apply security policies or the CRS rules against the gRPC policies? The GraphQL queries. Actually, if you use Coraza and CRS or mod security to test a GraphQL endpoint, you will only get a JSON containing the raw string of the GraphQL. And the most interesting topic that I think we should be discussing right now is edge termination. So as we have seen in the implementation mechanisms, there are so many right now. You can use eBPF, you can use HA proxy, but what can you sacrifice for security? I mean, do you have enough risk acceptance that you can have an asynchronous WAF? How can you handle edge termination? So right now it's a huge paradigm. It usually depends on your infrastructure and what are your capabilities of stopping a sessions and who are you stopping? And you're stopping a country, user IP address. Are you concatenating the user agent with the IP address, or are you going directly to the session? Or are you going directly to the user? That's something that isn't standardized now, and I'm sure most of you have had as problems. So if you see in the table here, there you see what are the sacrifices that you should make based on which part of your network you're going to place your web application firewall. Sometimes you will have to...
I've got a question about termination, and really the question is probably which bit of OWASP does this question belong in, that I could address it to them. I have the luxury maybe of not just terminating sessions. I want to watch them, work out what they're doing, work out what the intent is, and then address what that intent is. If I block them, they'll probably find another way in. Is that idea of, I mean, rate limiting is a classic way of, but it's a little crude. Is there anybody in OWASP that's looking at that? Let's learn, let's trap the traffic, let's see the intention. Where does that belong in OWASP, or does it belong in your project? Thank you. And the way X and stuff.
Thanks. So there's no straightforward answer for this, but we have been analyzing this, and this is a problem that concerns us because we are creating asynchronous connectors. And when people ask us, why do I want a WAF if I can't stop the attack? Well, I think in this year right now, it's not too much of a problem. I mean, you should think about the possibility of not using your WAF to block an attack. And there it comes, what's your security stack? I mean, if you can associate your current connection or your current transaction to a user, you can actually use your WAF to automate processes. For example, you can generate an alarm that will go to your SIEM, and your SIEM should there could be a hook that will access Redis and stop the session. It is there are many options, and I really think the WAF can be part of it, but not directly stopping. I mean, you can create a Coraza plugin to actually access Redis and delete a session. You can also connect to your firewall and block an IP address. There are so many actions you can perform from your WAF, but directly blocking the user might not be an alternative always.
Yeah, another thing that it's really interesting is like we are getting into the async world. So of course applications have been async for some time, but for a web application firewall that we expect blocks to happen in real time in a way, and we are thinking about maybe we can async this also, because once this enters our borders, there are many things that we can do. You can have, I don't know, your module, your machine learning, whatever. So you send the signal to whatever your infrastructure is in the background, and then you take an access control decision summarizing all the information they get. You can get your threat information from other place. So you just fire a signal with the information that you need, and then you take an access control decision afterwards with all the information. We can enrich so much now that it makes sense to start doing this in a way. So that's what we are thinking is this summarizes a bit on what can we do right now, but we are thinking forward, and this is an interesting problem, and we haven't discussed this as a community for open source projects. So thanks.
Well, cross-site scripting is not fun anymore. It doesn't only apply to cross-site scripting. It also applies to XXC and many other attacks. Even SQL injection. Today, if you want to inject an SQL injection vulnerability into your web application, you probably have to hack your SQL library because it won't allow you to run raw queries. So those vulnerabilities were the core of web application firewalls in the past 10 years, but they're not anymore. If you see the OWASP top 10, actually they have gone, cross-scripting is gone, and injection has been merged with so many attacks. So we should start looking to other things. Also, horizontal scaling. That's related to well, so in the past, WAF will scale using vertical scalability, and they will just add more memory and resources. But now we're talking about microservices, and we're also talking about auto-scaling groups. So your WAF has to go with you. So how can your WAF work with all your applications that need to fit your user requirements? And eventually the 0 false positives. This is the dream, right? This is the dream for all web application firewall vendors, for the CRS, for Coraza. Are we going to be flexible enough to allow false positives, or are we going to be so strict that are we going to be so strict that we generate many false positives? And we basically rely on signature-based rules. So sec rules is a non-dynamic language. You cannot adapt it during execution time. And API security. So as mentioned, we went to the API world, and it added additional variables. So right now, the arguments are not only the query string and the request body. We also have the path, which could contain variables. I don't know if all of you are aware, but you can inject an SQL injection into a URL without query parameters. So it has changed the way we handle attacks right now. And also with a new focus on API security in business logic. And now for a company, it might probably be worse to suffer from a broken object level authentication or broken function access. And of course, how we compete against the CDN WAFs. So WAF vendors right now, CDN vendors, they all contain web application firewalls. They're comprehensive, but how do we explain our users that they it cannot replace what would be an enterprise WAF, because there's not such flexibility. They're designed for minimum false positives, but maybe we need some false positive to be safe. And what we discuss about blocking the user, not the IP. So if you see the default settings for more security, it assigns the IP and the user agent as the session identifier. It's not okay. We cannot rely on that information. The attacker could be randomizing his user agent, or simply many users could be on the same network with similar browsers. And finally, after 30 minutes introductions, we go to Coraza. So Coraza has a modern focus on rich application. It is extremely guided by the community and the enterprise, but in terms of functionality, we support multiple connectors. We are tested on really rough environment. I mean, there has been probably trillions of requests processed by Coraza right now. And this is our mascot, Sancho. Also, we are 100% compatible with the core rule set, which is actually really interesting because libmod security is not that compatible with CRS.
Yeah, right now. So what driven this change, basically? As I said, as we said before, is the mod security is ending. It's ending its life on 2024. We don't know what's happening afterwards, but it's been driven for the past years by a company, Trustway, and it's actually been driven by them. So getting a pull request merge or getting something, a new feature or something, it's been really difficult for anyone, basically, because it depends on what the company wants. So when we started talking about this project and what's going to happen, and this is working well, we are doing so much progress, then companies started approaching us because this is a good product, they said. So we look around and say, we don't want to make the same mistakes. We want this product to be by the community and for the community. So in the end, we approached OWASP and say, hey, can we make this a new project for the foundation? Because this is what we want. We want this to be led by the community, not by a company. So there are additional companies that have been joining the project by their own employees, and they are committed and working on the project. And that's super interesting for us, because now the community says which is the roadmap that we want to follow. And the only thing we need is implementing. Right? And this is a massive change for the community because we have an option now that is not depending on a company. So this is why this project is super important for us as a community.
Our numbers. So we're a small project. We have 6 active developers, but there is a lot of work going on. I mean, with 6 developers, we are probably releasing 5 PRs per day. And the project is going through a super active development. There is a lot of testing. We are actively working to enhance API, to enhance performance, and enhance every aspect of the web application firewall, even new features. There have been we have 890 stars, 695 comments. Well, the numbers are right there. Okay, so this will become a bit boring now. Let's go to the internals. So, as Felipe mentioned, by Apache, we inherited the 5 Apache phases, which are process headers, request headers, process request body, process response headers, process response body, and process logging. So it actually does make sense, because most of the connectors and proxy APIs that are available in the market, they will provide you a wrapper to access the URL, the method, and the request headers at the same time. Then you will get the request body. Then you will get the response string with the response headers, and eventually you will get the response body. So the phases are marked here as how disruptive are them. So basically, greens are where you won't be able to stop the attack, and the blue ones are where you stop. And about the design, the Coraza. Coraza internally is designed for it's modular. For a plugins architecture, and it's also immutable, which allows us to export only a minimum of API. So it's actually relatively easy to implement. I will show you. So can I?
Yeah. Can you read it, right? Yeah. So also, I know it's funnier to just get your web application firewall compiled, like your mod security with Apache, but actually writing your own application firewall implementation using Coraza, because Coraza itself isn't a web application firewall. It's the framework you will use to create a web application firewall. Actually, with the core rule set, there it becomes a web application firewall. So you will create just an instance of WAF using the configuration API, and then you will use a list of directives. There is no need to use a list of directives. Coraza supports automatically creating every config and rule programmatically, so it can actually be done for there. And what you see here is all the lines you need to create a WAF transaction. I mean, this is a WAF. If you have a web application in Golang, these are the lines that you have to implement to have a WAF. So we will create a transaction, and this is super important. You have to always close your transaction with process logging and close. Coraza uses so many Golang optimizations that it actually has to clean the memory after running the transaction. Then you will start processing each one of the phases that we saw on the map, like process connection, process request headers, and you will be obtaining interruption objects that will actually interruption objects are objects that can be consumed by a web server or proxy, and it will tell it how to behave. The server itself have to decide whether it will use it properly or not. For example, it will say, hey, do some redirection. Hey, deny. And the server has to receive the action and say, hey, okay, I will do that.
Yeah, one of the things that we have as a library also is like you can write your own WAF, but also you can write tests for it. So that's super cool because you can reuse all the Golang tooling for writing your tests, and it's going to be extremely performant and really well tested. So that's another coolness that comes with the chosen language.
Okay. So regarding the benchmarks, it looks a bit unreal, but that's because we're talking about lib mod security. So if you use CGO, which is the C wrapper for Go in Golang, the performance you get out of Coraza is 40 times better, faster than mod security. Coraza is super optimized. It runs less operations than mod security in all aspects. I mean, for example, mod security will run for each match all of the actions that you have on the rule. Coraza, during Bootstrap, performs some intelligent selection of which actions are relevant, and it only stores the actions at the place where it should be run. So it won't repeat actions where they're not needed. And also it uses the read2 engine instead of PCRE, which is actually a huge bottleneck for web application firewalls, and also a source of denial of service.
Yeah, so I want to remark on that because we work together with Coraza. So the core rule set basically started working on getting rid of regular expressions that were only PCRE, because we know PCRE it's basically problematic because you can have regular expression denial of service, and it's not linear on the size of the input, right? And that's the main problem. So basically changing that for other engines like R2 or Hyperscan or whatever, then you have a different timing that only depends on the input, on the size of the input. So, and we are guaranteeing linear processing on that and only on that. So that's a cool feature, but that comes with all the work that CRS did to basically move away from regular expressions that were basically preventing other engines to do their work. So that was a really nice feature that CRS got into the next version, the next major version, which is not out there, but it's going to be soon.
So the deployment options. Coraza officially supports WebAssembly and CADI. We also have a connector for HA proxy, but it's experimental, so please don't use it. We get so many issues, and it's really, I don't know how it works. So, as I said before, we're really looking forward for WebAssembly because it's actually easier to export a single binary of Coraza for all web servers or proxies, rather than having connectors for each one of them. So right now, using WebAssembly, You can run Coraza on Envoy stable. And Nginx, there is a way to run proxy WASM. It's experimental and it will eventually come somewhere, but it can be done. Kong also through Lua supports WebAssembly. Also, it has a Golang connector that we're testing. And there's no use at all, but you can run Coraza in your browser. You can have an HTML WAF. We support Kadi Web Server. I don't know if any of you is familiar with Kadi Web Server. It's really fun because everyone is always aiming to Apache and Nginx, but Apache Kadi is a really interesting project. I have run benchmarks and I have tested it a lot. It is faster than Nginx in a lot of use cases, and it's really easy to integrate. Also, it supports auto TLS. It will automatically get a certificate from a public entity and assign it to your website, so you can deploy applications really fast. Also, you can use it on Kubernetes. There's an ingress controller module. And HAProxy, well, fun thing about HAProxy, also an HAProxy ingress controller that is being developed somehow took Coraza into their core, so using our SPOH connector, so technically you can use Coraza with the HAProxy ingress connector. And in-app, Coraza also has an internal middleware that you can implement into your Golang application. So basically, if you are running any HTTP service on your Golang app, with one line, you can add Coraza to perform all of the phases that are required. And the most important feature of Coraza is extensibility. So supporting WebAssembly and many other things is required us to have a modular structure, and it forced us it guided us into a plugin architecture that allows you to extend all of the capabilities of Coraza. I mean, if you want a new detection type using an operator, in 5 lines, you can have a new operator. You can also have new actions, like, for example, going to Redis and delete a session. You can have new body processors. You can extend it to add GraphQL, or if you have some custom type. A few days ago, we were discussing with Felipe some companies that sells frameworks that uses custom data structures to actually generate the requests. So with Coraza, you can actually protect them. Logging, for example, you could send your log to Elastic or some syslog if you want. Audit logging, the same, and directives.
Yeah, so one of the things that we did here is basically explore a lot of interfaces. So it's very easy to just match the interface and do your own. And then the sky is the limit basically there. So you just need to implement whatever you need. It's very useful for your needs. So it's very convenient for doing whatever you're thinking about now in the future.
And roadmap. There's no roadmap. The idea of Coraza is that features come from users, or if a user has a requirement, it fits what's the project. It doesn't affect how it works. It doesn't affect performance. It doesn't limit how which connectors can we use. Basically, we add it. We're a community project. We are not guided by some major interests. We literally will add. If any of you create a PR and it is useful, and you go to the meeting and say, "Hey, I really think this feature is cool," and everyone is, "Hey, I really like it," it's going to be merged.
Yeah, and I cannot stress that enough. It's guided by the community, and we have roadmap. We are planning on doing things, of course, in the future, but it's depending a lot on some of the things we talk now. We are thinking about, I don't know, GraphQL, and other things that we are seeing a lot is basically content types inside other content types, like sending JSON or sending HTML with JSON inside. So you cannot use the same parser because you're reading HTML, but then you're finding a lot of JSON inside. And that's driving us crazy because you cannot write specific rules for that in the case of the language. But if we have support from the web firewall, then there is a new thing that we can try. So it's basically a blanket for doing anything we want.
And finally, So, in conclusion to what we have learned from our project, we can live next to next generation firewalls. I mean, I haven't explained the concept, but people talk about next generation firewalls, which will add machine learning and everything. But what we have seen as results from the integration of CRS and Coraza, a signature-based web can still be part of it. Also, I do believe that there should be machine learning, open source machine learning for WAFs. It could be by the CRS side or by the Coraza side, but it is definitely something we constantly discuss. We must evolve to embrace API security and the new internet. I mean, it's not possible that we haven't considered in the current web application firewalls the possibility that there's a variable inside the path of a URL. We also have to think about the edge termination. I mean, edge termination is a core decision when you are implementing a WAF, and how you implement it will affect what's your performance. If you have zero tolerance of latency, then you can't use an inline firewall. There's no way. And enterprise communication is essential. I mean, we need the companies to be part of this. The great problem of mod security, I think, is that companies don't want to participate in the project because they're basically helping the competition. So there is no, that's not sane for an open source project. In the case of Coraza, we embrace enterprise. We talk with all of them, and they all reach us. Most of our users often reaches us. And here are the links in case you want to check any of this. I will close this because I will show you a playground. I will show you how to run a web application firewall in HTML5.
I have got a question. So if companies are not willing to participate in mod security, why would they participate in Coraza?
That because it's basically run by a company. The decisions right now are made by the company. The company decided that this is an online. So there is another story. When this decision came out, we basically started reaching the company. We talked with Andrew van der Stok. We started talking with Harold and tried to get the project landing in OWASP. But there was no conclusion from the company, and they are going to wait until things end. And we as a community cannot wait. We need a solution. So at least in our opinion, we need something now. We cannot say that we need guarantees on this, but we don't know what's happening. And maybe some other company is going to take it. Maybe it lands in the OWASP Foundation in the future or another foundation in the future, but we don't know.
But companies have their interests protected. That's why they don't want to participate in mod security. So why would they participate in Coraza?
I don't know.
They are already doing.
They are already doing it. Yeah.
There are many companies involved in Coraza.
Yeah, they are.
Yeah.
Maybe it's sexy.
Well, maybe it's sexy. I don't know, but or it's working for their requirements, and that's it.
Yeah.
We can guarantee that there is a lot of. I mean, time is short, right? But there is a lot of other things that we know that it's useful for, and the change of language also is useful for. One of the things that it's been a long time a problem for in mod security is languages other than English, for example, and things like that. And there is no support, and there is no timeline for that, and I think it's never going to be. But with Golang, you have that straight off the box. So that's another thing and we know it's being used a lot in China and others. We have a lot of users in China, and
if you're a cloud vendor and you want to add a WAF product to your company, the starting point is Coraza. Because there's an active development, and if you want something new, you won't have to get customer support. You will just create your PR, and it will probably get merged. We'll go through questions, but first I want to show you.
Oh, you broke it. No, I'm joking.
Oh, really?
You block yourself out.
Oh, what happened? Oh,
there you go.
Let me see if I can.
You
extend
never
this
can.
again. Duplicate.
Live demos. Live demo gods. Praise.
No, it will work. This is a. Let's spray to the demo gods. Yeah, the demo god worked. So this is Coraza in the browser. Literally, this is just an HTML application. There is no server. This is a GitHub page. So basically, you will type here.
Sorry about the colors. I think it's
Hacker colors.
maybe.
There it is. There's a Coraza transaction. These are the rules match. And these are the internal collections for debugging. So in theory, you could have here host.
So what you're matching here is basically the core rule set. So we are loading the core rule set. We're using the core rule set for matching, and that's what you're seeing there.
If you see here, we are matching SQL injection rules in an HTML application. And you can even, for example, here, where's the add character? Oh,
yes, there you go.
What's the word? Unconditional match. In the one message test. Okay, so if you see now, you basically extended the engine with a new test, with a new WAF rule. And you can even extend it to responses. This is a really great tool to debug your WAF. I mean, you can pass your request and response here and see how Coraza behaves. Or you could disable CRS and just run your own rules. So this URL is public. You can just go to playground.coraza.io and see how literally, please don't enter through your phone, it's not responsive. We are backend developers. Yeah, so, and this is it. Questions?
Yeah, can you go back to the links?
Oh, yeah.
So they have it. And yeah, we are taking questions. Are we good in timing?
We have
5 minutes. Oh, questions, 5 minutes, but we are going to be outside and you can reach us.
Think of the stickers.
Yes.
Thanks a lot for the presentation. I mean, and I can see there is a lot of work on Coraza, etc. I wanted just to go back to what you said about cross-site scripting, SQL injection, etc. And I tend to disagree in that respect. I mean, it's true that it's not the first one now, but it's still the third. And there are still many CVEs coming out that are about cross-site scripting, SQL injections, etc., etc. So if the WAF is not about stopping those kind of threats, then I'm a bit confused, to be honest.
Oh, yeah. So the WAF must protect you against SQL injection and cross-site scripting. It cannot do that. It's just the attack is not so common as it used to be. I mean, it's a core feature of Coraza, but it's also a problem. Right now, we rely on live injection. Actually, why Coraza works, it's because we managed to port the C project live injection a few years ago. So handling SQL injection and cross-site scripting is really hard because we cannot tokenize all the use cases of SQL. I mean, there's Oracle, there's Microsoft, there is MySQL, MariaDB, and they all take similar syntax, but they have their own tricks. So it's impossible to take them all. There are machine learning approaches that doesn't work that well. So, but it's really hard. And the same for HTML. HTML also now is evolving now, and it's really hard.
I think if you know your SQL dialect, you could make a module in Coraza for that.
So what we want to add is like, no, you're right. They are important. We are targeting them. But that's what you get with your classic WAF already. So the that's the importance of the rules. You're using the rule set on that, and that's basically it. we are thinking about what's next, basically, and what's going to hurt afterwards. So that's what we're trying to design for. But you're completely right. They are important. They are not as important as they used to be. I think that we wanted to stress that, and we are thinking about what's next. That's the only thing. Yeah.
I think we're
90 seconds.
Very, very quick question.
Yeah.
Can you do transformations on data? Like if you get
Yes. Yes.
Yeah, actually, there are like 70 transformations. You can do some decoding, you can do encoding, ASCII, Unicode. There are all kinds of transformations.
Yeah, and the sky is the limit, basically. Yeah, whatever you can program. Thanks a lot for coming. Yeah, we are going to be around if you have more questions. We are friendly. We are in, I guess, and we are in the. You can find us in the Coraza channel in Slack, in the OWASP Slack. We'll be around. We have meetings, remote meetings, but yeah, you're all welcome to participate in the community. Thanks a lot.
Thank you, everyone.